All right. Hi, everybody, both in the room and listening virtually. I'll be talking about our study today, Statistical Learning of Orthotactic Constraints, New Insights from Typing. And this is a result of a joint effort for myself and my co-author, Elizabeth Chu and Nazbanu Nozari. All right. Very brief background on phonotactics and orthotactics. Phonotactic constraints determine the possible combinations of phonemes in a language. An example would be the n sound is coda in English, like the example king, but never the onset. Of course, it could be different for different languages. And orthotactic constraints determine the possible combinations of graphemes in a language. Another example from written English would be X is usually the coda, like the example box, but rarely the onset. Phonotactic and orthotactic constraints are related, but not the same. For example, the V sound can be coda in spoken English, like the example dove, but rarely in written English. All right, so in the literature, phonotactic constraints has been extensively studied. Dell and colleagues in 2000 introduced the artificial constraint paradigm. So what they did, they had a sequence of 4 syllables, that nonsense syllables, embedded 3 different kinds of constraints. The first constraint is they called language-wide constraints. Specifically, H is always an onset, and N sound is always the coda. This is in line with spoken English that we've been exposed to for several years. The second category of constraints, they called experimental constraints, probably the most important one. Arbitrarily chosen for this experiment specifically, F is always onset and S is always coda. And the unrestricted category is the rest of the letters that is appearing equally often as onset and coda. So participants saw these sequences and recited them. So experimenter recorded their speech and looked at their speech errors. Their speech errors were coded either as legal or illegal. So if it's speech error, if a consonant is moving to preserving the syllabic position, like moving from onset position to another onset position, that error was coded as legal. But if the other way around, if a letter is moving from, let's say, from onset position to a coda position, then that error was coded as illegal. So what they found is, in terms of the percentage of legality of the error, experimental constraints and language-wide constraints were very comparable and statistically significantly higher than unrestricted constraints. Well, so what they concluded that participants quickly learn new artificial phonotactic constraints. As we see, they were able to cut up to the language-wide constraints that they have been exposed to for several years, even with one experimental session in training, let's say. After this strong and beautiful results, they wanted to look at the second order constraints. What I mean by second order constraints, again, specific letters have specific positions in a syllable, but this time contingent on a vowel. So for example, G is always onset and K is always coda when the vowel is A, and the other way around when the vowel is E. So these sequences were presented to the participants one after each other, so alternating between the vowels within the same experimental session. So it's a little bit more complex or confusing, you might say. But the rest of the experimental session was similar. So the people recited these sequences and looked at their speech errors. So what they found this time, in day 1, there was no sign of learning. So the pattern of legality of errors between experimental constraints and unrestricted group were almost exactly the same. But in day 2, they show a very robust sign of learning as the legality of errors in experimental constraints approach to the language-wide constraints. So and several studies replicated these pattern in day 2, the sign of learning. However, there were some other groups showing different learning patterns for, let's say, for children who were able to learn second order constraints in day 1. And there are a couple more other studies showing this kind of different learning patterns, but for the interest of time, I will not mention these, and I'm happy to talk about it in the Q&A. So motivating by these different results in second order learning, and mostly the studies are being conducted in phonotactic constraints. In the current study, we first wanted to ask, is orthotactic learning similar to phonotactic learning and dissociable from it? I will try to answer this question by experiment 1 and 2. This is, to our knowledge, is the first study looking at the orthotactic learning through typing. And the second motivation of the study is addressing the open questions from phonotactic learning literature, which I will try to answer with experiment 3. What are these open questions? The first question is, why are the second order rules learned on the first day in some studies and on the second day in others? One possibility is that children, due to their less mature production systems, make many more speech errors than adults. If acquiring new phonotactic constraints is driven by error-based learning, then the greater number of errors should drive the faster learning that is observed in children. This gives rise to the error quantity hypothesis. Since adults have less expertise in typing compared to speaking, then they are expected to make more errors in a typing study. So in that case, error quantity hypothesis would predict learning of second order rules on day 1 for adults in orthotactic learning. A second possibility is the existence of qualitatively different learning patterns in child versus adult cognitive systems. This would suggest the cognitive states hypothesis. Based on this, the number of errors should not drastically alter the pattern. Adults would still not learn the second order orthotactic constraints on day 1, even with more errors. And the second open question is, what is the possible mechanism underlying the learning of the second order constraints? While both onsets and codas are contingent on vowels, their different positions with regard to the vowel can be used to that different learning mechanisms. One possibility is that the constraints are learning in a strictly sequential manner, which would lead to the chaining hypothesis. For this hypothesis, the prediction would be that learning of second order orthotactic rules only for coda position, but not the onset. Another possibility is that constraints are learned hierarchically, which means learning to relative to a frame, and this would lead to hierarchical learning hypotheses, and the prediction would be learning of second order rules for both onset and coda position in a similar way. So now switching to our experiment 1, we looked at the learning of first order orthotactic constraints in typing. Similar to spoken production studies, we had a sequence consisting of 4 nonsense syllables, and we had the similar embedded constraints. So the first one is the language-wide constraints. For our study, it was V is always onset and X is always coda. Just note that these are orthotactic constraints instead of phonotactic, and these are in line with the written English general rules. And our experimental constraints included T is always onset and S is always coda. Of course, this was the other way around for the half of the participants. And the last category is unrestricted, similar to the spoken production studies, appearing equally as often in onset and coda position. So we had participants hear these sequences and then type them, and we analyzed their typing errors. We had 24 participants, 96 unique sequences repeated 3 times, only conducted in 1 session, and overall, a little over 5,000 errors elicited. Just to note that this rate of errors is a lot higher than the spoken production studies. Okay, what we found in experiment 1 is very clear pattern. The legality of errors for experimental constraints and language-wide constraints were very comparable, not different at all, but both drastically higher than the unrestricted constraints. Just to remind you, this is very similar to what they found in spoken production. So what we concluded is that new orthotactic rules are learned as quickly as new phonotactic rules. Switching to the experiment 2, this time we are asking, is orthotactic learning really orthotactic? So we saw in the first experiment, there is robust orthotactic learning, but we don't know if phonotactic learning is interfering this at all. To be able to answer this question, we use the phonemes S and C. So S and C is special in a way that depending on the position in the syllable, they could produce the same sound like fes and sep, and there would be a phonological overlap, although they are not orthotactically in the same position in the syllable. And again, depending on the position, they could produce different sounds, fes and peck, and there would be no phonological overlap. So by using this feature, we had 2 different groups of participants. The first group So the experimental constraints in the phonological overlap condition, which mean that C is always coda and S is always onset. So that group heard the same sound for these two different letters. And the other group had the experimental constraints with no phonological overlap, which S is always coda and C is always coda as well. The rest of the constraints were pretty similar to the first experiment. This time we used restricted constraints instead of language-wide constraints. So we already proven that there is learning for first order constraints, and we put this restricted constraints here as a point of reference, you might say. So the rest of the experiment were pretty similar to the first experiment. We had 24 participants, 96 sequences repeated 3 times, again, only with 1 session. And overall 1,300 errors were elicited. All right, I show what we found, since this is a little bit of a novel design, I'll show some predictions to be just a bit more clear. So the prediction 1 would be significant interference from phonotactics. If there's a significant interference, then we would expect some differences between the 2 different experimental groups. So the experimental group with no overlap, we would expect would be pretty similar to the reference point restricted constraints. But if there's an interference from phonotactics, then we would expect experimental group with phonology overlap would be similar to the unrestricted, because supposedly participants could get confused with the interference from phonotactics. And the second prediction would be little to no interference from phonotactics. In that case, we would expect no differences between the 2 different experimental groups and comparable to the restricted. Okay, so what we found is, just putting the predictions there as a reminder, was pretty similar to prediction 2. We did not see any differences between the experimental groups, no overlap and phonology overlap, and they were comparable to the restricted group and significantly higher than the unrestricted group. So what we conclude based on this is learning of orthotactic constraints is dissociable from phonotactic constraints. All right, moving on to the third and the last experiment, learning of second order orthotactic constraints in typing. In this one, again, adapted from the spoken production studies, we had our experimental constraints contingent on a vowel. Specifically, K is always onset and F is always coda if the vowel is A, and the other way around if the vowel is I. Again, participants are exposed to these constraints within the same experimental session. Vowels alternated one after each other. And for this experiment, again, same way, participants hear these and type them. So the specifics of this experiment, there's 20 participants, again, 96 sequences repeated 3 times. This time, the most important difference, they were tested in 2 sessions, completed in 2 different days. And in the first day, they elicited a little over 5,000 errors. And in the second day, it was around 4,300 errors in the day 2. Again, just as a reminder, these are a lot higher error rates than the spoken production studies. And the first pattern of results I would like to show is the learning pattern. So in the first day, we found pretty similar legality of error, percentage of legality errors for unrestricted and experimental groups, no significant difference in between. This would suggest no learning of experimental constraints. But in the second day, there was a significantly higher legality of errors percentage-wise in experimental constraints compared to unrestricted constraints, which would indicate the robust learning on the second day. And just to remind you that this pattern is pretty similar to what they found in spoken production, despite the fact that we had a lot more number of errors. So then concluding that number of errors did not play a major role in second order constraint learning. Okay, moving on to the last pattern of results is we would like to look at the difference between onset and coda learning. So I'm only showing here the second day of results because that was the day that we saw some learning. So on the onset position, we actually did not see any difference between unrestricted and experimental constraints, but on the coda position, experimental constraints, the legality of errors were pretty much comparable to the language-wide errors. So what we concluded is that second-order constraints are learned for the coda, but not for the onset position, suggesting learning in a strictly sequential manner, kind of indicating the chaining hypothesis. All right, so to recap, is there a question? Sorry.
Oh, no, I was just about to say, I hate to be this rude, but it is time.
Okay.
So I would suggest that we go to the Q&A, and hopefully the slide will be here to remind the audience of what the main conclusions are. I apologize.
No, that's okay. Okay, this is the conclusion slide anyway. So I'm happy to take any questions, and thank you for all the collaborators. All right.